Section 12.2, number 20, evaluate the double integral. Double integral of 2x y dA. D is a triangular region with vertices 0, 0, 1, 2, and 0, 3. I think this is a perfect example of where sketching the region is a fine idea. All right, so we have 0, 0. Hold on, 0, 0. 1, 2, over 1 up 2 is about here, and 3 zeros over here somewhere. About 0, 3. All right, so I need more room up than down. So 0, 3 is up here, 0, 0 is here, 1, 2 is about here. All right, let's label these ordered pairs. 1, 2, 0, 3, 0, 0. All right, so looking at this through the lens of which is easier to start with, left to right or bottom to top. If we go left to right, we got a slight issue because the left side of this lamina is one segment, that one there, but the right side of the lamina is made up of two separate curves, if you will. So if we were to do left to right, so dx first, x equals on the left, x equals on the right, the right side has x equals something on the top and x equals something else on the bottom. So I think we'd be better off doing bottom to top first, because bottom to top, the bottom of the lamina is this segment and the top of the lamina is that segment. So with this observation, we are going to do the D, well, let's make that a little bit better. We're going to do the bottom to top. So that would be y equals on the bottom, y equals on the top. So we're going to do the dy integral first of 2xy, followed by the dx integral. Okay, so now that we made that decision, we need to figure out what y equals on the bottom and what y equals on the top. Well, this is just coming up with the equation of a line given 2 points, so I'm not going to spend a lot of time doing college algebra with you. The equation of the bottom line is y equals 2x. The slope is 2, the y-intercept is 0. The equation of the top is going to be y equals negative x plus 3. The y-intercept of the line on the top is clearly 3. The slope is negative 1 if you were to do the slope calculations, which means if we do the dy integral first, then the bottom boundary of our lamina is y equals 2x, and the upper boundary of the lamina is y equals negative x plus 3. And then when we do the dx integral, we just need to know the constants on the left and the right side of the lamina. On the left side of the lamina, x is equal to 0. And on that one corner on the right side, x is equal to 1. I think the setup is the hardest part about this one. The evaluation should be pretty straightforward. All right, so let's do the dy integral first. Come on. There we go. Integral from 2x to negative x plus 3. What was our integrand? 2xy. And we're doing the dy integral. All right, so with respect to y, the integral of 2xy is 2x, how about xy squared? I was going to say it's 2x times 1/2 y squared, but of course, 2 times 1/2 is 1. And this is going from y equals 2x to y equals negative x plus 3. Okay. Evaluating at the upper limit, if we let y equals negative x plus 3, we get x times negative x plus 3 squared. And I think I can get rid of this. Not all that, just that. Okay. And then if we evaluate the antiderivative of y equals 2x, we get x times the square of 2x. Now let's see what all this equals. If we square negative x plus 3, we get x squared minus 6x plus 9. Hope you didn't distribute that square. And if we simplify the right side of the subtraction problem, if we square 2 and square x, we get 4x squared times another x is 4x cubed. And if we just gather all the like terms, we will have another x cubed term here. X cubed minus 4x cubed is negative 3x cubed. And then continuing the distribution of the x, we get negative 6x squared plus 9x. So we'll integrate that, and I believe it was from 0 to 1. Yes. Negative 3, negative 6, and 9. All right. Negative 3x cubed. Is it negative 6? Negative 6x squared plus 9x. We're going to integrate that with respect to x from 0 to 1. The antiderivative is negative 3/4 x to the 4th minus 2x cubed plus 9/2 x squared. And this is going from 0 to 1. 0 will annihilate the antiderivative, so we just have to evaluate it at 1. And evaluating it at 1 is just combining the coefficients. So negative 3/4 minus 2 plus 9/2. Common denominator would be 4. We'd have negative 3 minus 8 plus 18. Yes. Yes. Let's see, 18 minus 8 is 10. 10 minus 3 is 7, so we should get 7/4. All right, so again, the hardest part about this one was getting this set up. And in this case, sketching the region was critical because it made it clear that this would be easier to integrate from bottom to top first because the bottom was just this one segment down here. Let me turn on the highlighter. The bottom was just this one segment here, and the top was just that one segment there. Whereas if we try to do this starting from left to right first, although the left was just one segment, the right side was formed by two segments, and therefore we would have to split it up into multiple double integrals. Cool.